Welcome to week 5. This is going to be problem number 1, and I just wanted to remind you or inform you that if you're working a problem in MyStatLab, the icons on the right provide a series of help or assistance, one of which is a video link. If you click on the video link, it takes you to a page that directs you to a video for the relevant chapter. Click on that, it takes you into the video produced by the authors of the text and I think also presented by them. And this week's video is just under 9 minutes long, and the videos are typically very good summary, which is great to look at after you have read the chapter and before you attempt to do the problems. So onto the problem for this week. We have 4 probabilities to calculate from the information given that at your school 9% of the class are marketing majors. You are randomly assigned to 2 partners. You want to find the probability that the first partner will be a marketing student. Now, if you think of what probability is, it's going to be the number of successes divided by the total number. Now, when you calculate this ratio for your school, we know that it's going to be equal to 9%, which is 0.09, because that's the ratio of successes, which is that in this case the person is a marketing student, and therefore the probability which we are going to use as A, that the first person is a marketing student, is 0.09, and that's what the explanation here details. A reminder that the probability has to be between 0 and 1, and in this case we're given that is 9%, so the probability is 0.09. Moving on to the second part. What is the probability that the first partner won't be a marketing student? Now, if we were to look at it, the complement rule really says that the probability of an event A plus the probability that is not the event A, that must be equal to 1. So what that means is that if this is 0.09 and the probability that the first person is not a marketing student is unknown, then this expression holds true. And if we were to solve for this part of the expression, then you would end up with the probability that the person is not a marketing student is equal to 1 minus 0.09, which is 0.91. And that's what is stated here. And the complement rule is stated a little bit differently. In the text, it states that the probability that it's an event A is equal to 1 minus the probability that is not an event A, which is identical to what was shown here, which is the sum of probabilities that it is A plus that it's not A, that must be equal to 1. So whichever way is easier for you to digest is okay, because they're really saying the same thing mathematically. Part C wishes to find the probability that both will be marketing, and the probability of A and B is the probability of A times the probability of B, and we know that the probability of the second person being a marketing student, if we were to go back to the 9% in the school, then that is also going to be equal to 0.9. So the probability of A and B is equal to the product of probability of A times the probability of B, and this works out to be 0.081. The general multiplication rule goes into a conditional probability, And when you read through or listen to the video, you will recognize that because these two events are independent, then the probability of B given A is equal to the probability of B, since both A and B are independent, which is why this general multiplication rule translates to this here, and this is an oversimplification because we know that events A and event B are not dependent on each other. Part D seeks to find what is the probability that one or the other will be a marketing student. Now, the general addition rule states that probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And if you were to think of that and substitute the responses here, we calculated the probability of A and the probability of B and the probability of A and B earlier, so that this expression here gives you the probability of A or B, remembering that A represents the first person selected and B represents the second person selected, both of them being marketing students. So the probability of one or the other being a marketing student is 0.1719. And this last slide here is actually taken from the text, and it shows you a lot of the rules that we applied and some more. So you want to take a look at this. Go ahead and look at the text. It's on page 203, and you should be fine completing problems similar to this. Alright, thank you for watching.